Hello everyone. In this video, we will discuss the security section. The security section can be done and explained in this way. They are zone-based firewall and app-aware firewall. We will discuss these two strategies together. Then we will introduce service insertion, IPS and URL filtering. Since our test bench cannot access the internet, we cannot demonstrate the specific phenomena of URL filtering. We will discuss these two security strategies. In traditional firewalls, there is zone-based access control and filtering. What's the difference between this and zone-based in SD-WAN? Besides inheriting the characteristics of traditional zone-based firewalls and firewall features in SD-WAN configuration, it is not only possible to control between sites, but also traffic control between site A and site B. A new feature is within a site zone. Access can also be controlled within the same zone. This is what differentiates it from past firewalls. For firewall actions, there are 3: deny traffic 2, filter traffic through the firewall, and 3, pass, which allows traffic through, making 3 states in total. Next, let's look at how to configure a zone-based firewall. And during the process of matching zones, we add application recognition. Here is a screenshot of my operation process. Adding a security policy. Here it is customized. Creating a new firewall policy. Okay, we choose to add a zone. Here we are simply creating one zone, Zone 1, equivalent to the same zone within 2 sites. For access control, we have chosen VPN 10, this zone, this VPN. Then, to implement the policy, note that we need to identify applications. So I combine zone-based firewall and app-aware functions together. Here, our firewall needs to be able to identify the ICMP protocol and recognize the SSH protocol. By controlling these 2 protocols, we prohibit ping operations and allow SSH to pass through. Here we can choose inspect. During the experimental operation, what I did was inspect. When saving the policy, during that time, there is a bypass option available. This option is used particularly for our transport and for situations where we have implemented NAT. They all need to be bypassed, not subjected to zone-based firewall or application identification firewall processes. Not applying the application recognition firewall. Regarding the application of the firewall, note it is different from the activation of previous strategies. It is included in our templates. Everyone should pay attention. And this policy is a local policy. It will not be applied to devices globally. You need to specify a specific device to use this firewall. Regarding the tests, we use ping between PCs and SS between PCS as 2 applications for testing. We introduced zone-based firewall and firewalls capable of recognizing applications. Previously, I mentioned combining these 2 features to work together. Why they can work together is because there's a prerequisite. We need to enable the DPI Deep Packet Inspection feature. DPI, Deep Packet Inspection, can only be utilized once this feature is activated. Only then can applications within the traffic be identified and application-based firewall policies be implemented. This application, from a command line perspective, involves this particular command, and from a functional and policy standpoint, is essentially a check. We also integrate this application into our architecture, calling it through templates. Next, we'll switch to the experimental scenario to see how it's done. Lastly, when it comes to DPI, we first inspect the DPI. DPI is a localized policy named DPI. We edit PTA. DPI shows we just need to check an application, meaning when traffic passes through Sedge, we identify the traffic, recognizing whether it's an HTTP, FTP, SSH application, etc. We configure this functionality on how to apply it in the template. Let's look at the template. Template. Note that I have enabled DPI on all devices. This is something to be aware of. Waiting to log in again. Select one or two templates to check. The template I chose, Edit, here is invoked by attaching templates. DPI is called within the template. I have already prepared all the experimental level invocations. They are all the same. We won't check them one by one. Next, let's look at the security policy. In the security policy, I defined a local policy and gave it a name to block the ping command. Allow SSH. How is it done? Let's see. Policy edit policy. First, the same zone was created here. Note that the source zone and destination zone are the same. This is a name. After configuring the zone base, next define the rules. The first rule blocks the ping command. Block. The protocol number for ping is 1. I match the protocol number. My action is to mean to prohibit ping. Then SSH is allowed. I don't control the source and destination. As long as it's the SSH protocol, I can inspect. The condition is met if the protocol I allow it to communicate. This is our current policy. The policy has not been invoked yet. The invocation of security policy is localized, called in the template. Similarly, we find a template to first check the configuration. The invocation of the security template is in the security policy. I apply it on Sedge. Let's check whether the functionality of our current zone-based firewall is achieved. The test target. Let's look at the topology diagram. The topology diagram is from the BR side to the DC side, which is not accessible, but SSEs is possible. For the PCIe, the 10 network, 10.103. This is the BR test machine. 10.103 received no response. The ping is not working. We use SSS. Received a response. Username mismatch. It's because of a username mismatch. I will change the username. I successfully logged into the PCI PC through Edge. No problem with DC1's PC. Now, revoke this policy. Conduct a ping test again, update. Next configuration. Waiting for the update. Test again after the update is successful. After revoking the policy, the ping operation was restored. Okay, next, we will quickly discuss the second policy, which is service insertion for devices. Device, it has an application scenario. Let's first look at the big picture. In real production links, DC is our headquarters. Our headquarters often deploy firewalls due to the majority of cases. Branch offices, due to fewer people and smaller scale, do not have firewalls, but they also have security needs between accesses. What to do then? We can publish firewall services, treating the firewall as a service and publish it through OWN. To recap, in the last lesson, when we talked about OWN, he mentioned that OWN has a feature that can publish our applications as a service. I think it can be published as a service. At this time, branch office traffic will go through the firewall, through the traffic filtering of the firewall, and then to the target being accessed. This plays the role of firewall security. In DC, through templates, we publish the firewall, publish the service. Template for DC service, I need to find the service just now. This service is not in our global templates. We need to switch to the feature template. In VPN 10, VPN 10 is for DC1. DC1's VPN 10. Edit this template. Create a service here. This service is for firewall. Assuming the IP address, the router is my firewall. Its address is 10.4.192.168.104. 10.4. Preparing to update this service. The service will be updated shortly. You can check this service in OWN to see if the service is successfully published. DC1 OWN announcements. Just looking at application 10. I switch to 4 or 5, either is fine. For VPN 10, it's receiving all. It's a service. Here we receive some services. Let's check the routes again. No display receipt, like it needs an update. There's a slight issue here. I should have received some routes. Now, we're going to create a policy. A centralized policy. It's in the form of routing. Creating a service insertion, adding a name to it. Routed traffic to DC. Which traffic exactly? Firstly, site branch office site VPNs list. Is the core VPN. Match this condition, what action to take. Assign it a service. Firewall service. The VPN number is 10. Then change the default setting to accept. Save our policy. Give it a name. Here are the outbound routes. Need a minor adjustment. This is inbound. I need to switch to outbound here. For the outbound routes of BR, we need to channel them into the firewall. Next is the activation. Activate this policy. To save time, we quickly configure and deploy. Now, the policy is set. The test plan remains the same. From BR2 to BR1, we have a convenient graphical test. Switch to the device settings. BR2 conducts the test and tracking. Heading to the target exchange. The target is 20.101 on VPN 10. The first hop is to 20.1. Where is 20.1? It's our DC1, CSR 1104. Then out to 10.1. Then out to 10.1 is DC1's edge 1 returning to BR3 to complete the communication, meeting the firewall feature requirements of the device. That satisfies the device's firewall feature requirements. These two security features are where we conclude. This is all about today's video. Thank you.